Hello guys, this is Bhupendra Singh and you're watching our YouTube channel SME Dehradun. I have got lot of queries regarding the soil moisture sensor like not providing the accurate values, sometimes not working properly or getting reverse values etc. So I think I have to made a video on it that will resolve all of your problems regarding soil moisture sensor, right? So let's start. When you open the new packet of the soil sensor, you will find two parts inside as you can see. One is the soil moisture sensor that we put into the soil and second is its interfacing board. So let's connect the sensor to its interfacing board. Take two wires and connect it to the soil sensor. In the interfacing board, there are 4 pins: VCC, ground, D0 and A0. We connect these pins to our microcontroller board to fetch the data from the sensor. Take 3 wires and connect them to the interfacing board. And this is the Arduino Uno. Connect the VCC pin of the soil sensor to 5 volt, ground to ground, and A0 pin of the sensor to the A0 pin of the Arduino Uno. I will show you the soil moisture sensor calibration with the help of Arduino Uno. So our connection has been done. Please take the reference from this circuit diagram if you have any confusion in the connections. We are not using digital pin of the soil moisture sensor in this program. Now time for the programming code. Open the Arduino IDE. As you know, we have two predefined functions in our Arduino programs: void setup and void loop. Here at the top of the program, we will take the sensor as an integer type and store A0 in it because we have connected the sensor to A0 analog pin. We also define soil as an integer to store the sensor data. In the setup function, we will begin the serial at 9600 baud rate. I have also given the delay of 2 seconds so that AVR GCC compiler go to the loop function after the delay of 2 seconds. Inside the loop function, we will store the analog value of the soil moisture sensor in the soil variable. And I am serially printing the raw value of the sensor data to the serial monitor. We also write the delay of 2 seconds so that we can fetch the soil data every 2 seconds. Now upload this program to Arduino. Connect your Arduino Uno board to the computer. Go to the tools and in the board section, select the board as Arduino Uno. Again, go to the tools tab. In the port section, select the port as COM9. It may be different in your computer. After it, click on the upload button. I don't have soil right now, so I have taken a glass of water so that I can show you the calibration of the soil moisture sensor. Sensor will work similarly if you want to test it with the soil, right? Let's open the serial monitor. As you can see, while the sensor is not dipped into the water or into the soil, then it is given the value as 1023 in the serial monitor. While I am dipping the soil moisture sensor into the water slowly, then the values are going down. When the sensor is completely dipped into the water, Then I get the lowest value as 409, 4010 in the serial monitor. Have you noticed, guys? Sensors are giving us the opposite values. Means our values should be low while not sensing the water's content, isn't it? Please avoid the value 0 because there is some issue with the connecting wires that I have used to connect the sensor with the Arduino board. So what do we do with these values of the sensor? We need minimum and maximum values so that we can prepare the chart, map the values and calibrate them as per our requirements, right? But note it, guys, sometimes value may vary, so you have to measure it carefully. So now we map these values using the map function. Map function is an inbuilt function in the Arduino IDE. So inside the map function, we write the soil variable in which we read the soil sensor value. After it, we will write the maximum value that we received from the sensor. And after it, we will write the minimum value, that is, I think so, 460. Now I am inverting these values in between 0 to 100. What is the meaning of it? Our map function will convert the values that we are getting from the sensor between 1023 to 460. Okay, and it will be converted to 0 to 100. We will store these values to the soil variable again. So guys, you need to map the values that you are fetching from the sensor as per this map function, as I do. I think it is very simple. Now upload this updated program to the Arduino board. Open the serial monitor. We are getting the 0 value in the serial monitor because I haven't put the sensor into the water yet. Now I am dipping the sensor. While I dipped the sensor completely, then the sensor gives the maximum value to 68. Okay, I think I have missed the minimum value somewhere. So I will print the raw data of the sensor in the program here. And printing the values after the map function here. Again, I am uploading the program. Now open the serial monitor again. I am clearing the serial monitor. I am getting the value 0. I am slowly dipping the sensor to the water. While I dipped the sensor completely, then I got the value as 651. You can see it here. So I have to change the minimum value to 650, right? And upload again. In the serial monitor, we are getting the right value from the sensor. Maximum value is 98, 99 and the minimum as 0. That's great. We can say we have created an accurate programming algorithm for the soil moisture sensor that senses the water content from 0 to 100% accurately. You can put this programming algorithm in any of your plant monitoring projects. Now I am adding the alert message in the serial monitor so that while the sensor senses the water to a certain level, it will print the alert message, right? Here we put the if statement. If the sensor finds the water contents greater than or equal to 80, then we will serially print that enough water for plant, right? And inside the else if statement, we print that water is low while water content is less than or equal to 40. And below in the else statement, we print the water level is okay. Upload this program to the board. Open the serial monitor. As you can see, the row value is 1023 and the mapped value is 0. We are also getting the warning as water level is low. Now I am slowly dipping the sensor into the water. As you can see, while the sensor mapped value is 63, means when the values are between 40 to 80, then we are getting the warning as water level is okay as per our programming algorithm. And while I am more dipping the sensor to the water, then I am getting the values as 84 and 100. And I am getting the warning message in the serial monitor as enough water for plant. So guys, this is how you can calibrate the soil moisture sensor for your plant. You can use the same method to map the values with the ESP32 Wi-Fi board. But if you are thinking of using a soil moisture sensor with NodeMCU ESP8266, then please be careful because the analog pin of the NodeMCU is not too accurate. You need to do so much hard work to measure, calibrate and map the values. And I am damn sure if you follow this method to calibrate the soil moisture sensor, the sensor will work with your project perfectly. If this video helps you, then please like and subscribe to my channel and videos. And if you want any kind of help in your project, then you can write your comment in the comment box. I will definitely help you to resolve it. So thanks for watching. Please stay with us for more innovation.